Hello students, welcome to the next lecture on the PY question series. Today I will explain you how you can solve all those problems related to the Cramer Rao lower bound. That's the part of the estimation. Myself Dr. Harish, you can simply follow my YouTube channel where you can find the playlist and you can see the first playlist, the gate statistics. The last lecture was on the MVUE. So before watching this lecture, I recommended you can watch this lecture and this lecture deeply so that you can understand this lecture very well. Apart from them, there are many other lectures available in this playlist. There is one more playlist named as the IIT JAM solution, and you can see the various mathematics and the statistics solution is available in this lecture. So the maximum likelihood estimator, unbiased estimator, all are available in this lecture. Now, what is the Cramer Rao inequality? So if you have that T is the unbiased estimator of any gamma, so firstly you have to prove that this is the unbiased estimator, and I already explained you in my last lecture that is the unbiased estimator. Then you can find the lower bound of this unbiased estimator is given as here. That is whatever the function of this, you can find the first derivative divided by I, where I is the information here and capital L is my maximum likelihood estimator. Instead of this, I always use this formula for this. This is the lower bound, which is called as the variance of the T is greater than or equal to this. I can define the capital I is minus second order partial derivative of log L. Now based on this single one tips, I can solve each question in a very simple manner. But remember that before using the Cramer Rao lower bound, you must know how you can prove that anything is my sufficient. Secondly, how you can prove that anything is my complete. Fine. And the last thing is how you can find the MVUE. So based on these simple shortcut tricks, I can solve each question in a very simple manner. All these shortcut tricks is available in this lecture named as PY question on the MVUE, and you can see it's a complete length is available. Now let's start with the first question. You can see they are talking about the Cramer Rao inequality of this estimate. Fine. So what is the formula for this? Variance of the T should be greater than of if I have a G, so I call as a first derivative square divided by I of theta. Fine. Now what is the capital T? It is not given to you, so firstly we will find it. I can firstly find the I. What is my I is expected value of minus second derivative of log L. So firstly I can find the function. What is the function is? It's a Poisson distribution, e raised to power minus theta, theta raised to power x over x factorial. Now since it's a function is on the theta, so I can only take the function which is dependent on the theta, that is my here. So can you define the L? If the sample size is n, so e raised to power minus n theta into theta raised to power sum of xi. So I can define the log of L. Log of L is minus n theta plus summation xi log of theta. So I can firstly find the first derivative of this, minus n plus summation xi over theta, and the second derivative is a 0, is a minus summation xi over theta scale. So what is the my I? I is expected value of minus of this value, so it's a minus minus plus 1 over theta square is outside summation of xi. Fine. So what is that? As xi follows the Poisson distribution with the parameter theta, then sum of the xi will also follows the Poisson distribution with the parameter n comma theta. So what is the expected mean of this? So we all know the expected mean of the Poisson distribution is lambda. So it will be n over theta. So I can substitute this value here. What is the mean? What is the G dash? So I can write here. So what is the Cramer Rao lower bound? What is the derivative of this? Is the first function minus theta times of this divided by I. I is my n over theta. So I can take e raised to power minus theta is common. So it will be here 1 minus theta divided by n, and you can check about the option. Theta, it's a minus of theta, but we need a 2. This is minus theta 2. I need a divided by n also. it is cancelled. So A is my right answer of the problem. So this is the way I can always solve each problem. Make sure your target is to find this value as here. Okay, there is one more way. How you can find, if somebody will ask you what is the, clearly say this value is my sufficient estimator. Also this number is my open interval, so this number is my complete as well. Fine, and you can find this. Look at this next question. Xi's are my random samples with follows normal distribution here, where both are my unknown. Which of the following statements are my true? MLE of mu. So you all knows what is the MLE of mu. This is x bar. Then MLE of mu attains the Cramer Rao bound. Fine. So that's very simple. It means your target is to find variance of the x bar, because MLE of mu is, that's x bar. X bar attains the Cramer Rao, that means of this. So what is the x bar? X bar will follows the normal distribution mu and sigma square by n. So this value will be, what is the x bar? Sigma square divided by n. Now how I can prove the attainment? So again very simple, I can apply this definition. So x bar is the unbiased estimator of mean. Fine. So what is the variance of x bar? This is g dash, I call this is my g divided by I of theta. Fine. So this number is my 1 over expected value. So I can define the function. This is 1 over 2 pi sigma e raised to power half x minus mu whole square. So let me clear this screen here. Fine. So what is the L? So since I need only with respect to mu, so I can return this is minus half summation x minus mu whole square. I can take the logarithm. So logarithm will be minus half summation, sigma square also. Fine. Half sigma square x minus mu whole square. Now I can differentiate with respect to mu 2 times. So minus half sigma square is outside, 2 times summation of x minus mu, and the derivative of mu is my minus 1. So it is cancelled out. What is the second derivative is here? X will be 0, so it's a minus summation of 1. So summation of 1 will be n. So n over sigma square. So what is the lower bound of the x bar? G dash, that is a 1 square over expected value of this. So this is a constant number. So expected value of this, what is that? Sigma square over n, and which is the same of the variance of x bar. So yes, it attains. Second part is the minimum MVUE of mu attains the Cramer Rao bound. So can you find the, how you can find this value? So as I already explained you in the last lecture, what is that? Firstly, the function is given to be by this minus half x minus whole square. So clearly say if you open this square, that one term which involvement of this here. Fine. So what is the meaning of that? The coefficient of the mu, that is the x, is my sufficient estimator. Also because mu is given in the open interval, or it has an open interval, so that means this is a complete also. Fine. So this, the mu is the complete. Now I can find the expected values of this. It will be, summation will be outside, it will be my summation of the x is mu, so it is my n mu. So what does it mean? If I divide it by summation of x over n is my mu. What does this mean? This means this x bar, what is that? This is the x bar is the unbiased estimator of mu. So what is the UMV of mu? Is the x bar, so which is the same of this previous one. So that's also the attain. So that means the first part and the second part has the same meaning, but it is written in the different form. Okay, look at this next question. The MLE of sigma square. So we all knows what is the MLE of sigma square. It is because this mu is my unknown. Fine. So if it is unknown, then I have to write this 1 n minus 1. So this is xi minus mu whole square. This is the MLE of this. So this is the unbiased estimator of this. So what is unbiased estimator? I have to compute this value. Fine. And our target is to prove this is a sigma square. So what is that? We all know this value is my sample variance. Fine. And what is the I can take n minus 1 is outside, expected value of this summation is outside. Fine. So what is that? This is the variance. Fine. So it will be n minus 1 sigma square over n minus 1. So it is my sigma square. So yes, this is also the MLE is the unbiased estimator. Why it's n minus 1? Because this is the unbiased, because mu is my unknown. Because mu is my unknown. If mu is my known, then what is the summation of this is n into sigma square. If mu is my known. Okay, look at the last option. The relative efficiency of sigma square with respect to the uniform minimum variance estimator of sigma square. So what is the MVUE of sigma square? This one. Fine. If I call this is my S square, then it is my S square. Fine. So what is the relative efficiency means? Variance of S square because this is a with respect to. So I have to return with respect to firstly. Fine. Now can you find the value of variance of maximum MLE of sigma square? What is the MLE of sigma square is? So I can substitute this value here. This is variance, so n minus 1 whole square, variance of this value. So what is the variance of this value? It is a n square into sigma square. Fine. So this value will be cancelled out. This is the variance of h square. So the answer is n minus 1 over n whole square. So clearly say this number is less than 1. So all are my correct answer of the problem. Okay, xi follows the Poisson distribution here. Define the x bar. So what is the x bar? X bar will follows the normal distribution always. Fine. So what is the mean of this? Is lambda. Variance of the Poisson distribution is also lambda. So here. So that means of this. Now I start with this one. What is the expected mean value of the x bar? Lambda. Fine. What is the expected value of the S square? So how you can find this? So firstly I can find the distribution of this. Xi follows the follows the Poisson distribution. Sorry. Okay. So whenever square is written, what does it means? Whenever the square is written, we will always work on the chi-square. Fine. So what is the mean of this xi minus x bar? What is the mean of this? Can you find the mean of this? It will be, I can write it directly. There is no need. If I divide it by variance, fine, because what is the chi-square is x minus mu divided by sigma of whole square. And you know what is the mean of the xi is x bar. If I divide it by the variance, what is the variance of the Poisson distribution is lambda. So if I divide it by lambda square, there is a variance and it is my lambda is here. Fine. Then what does the meaning of the S square? It will be, so S square will follows chi-square of n minus 1. Fine. So what is the expected values of this value? So what is the, if x follows the chi-square degree of here, what is the expected value of the x is n. Variance of the x is 2n. So now I need the expected value, so it is a n minus 1, which is lambda. So this value is also lambda. So both the values are same. Yes, this is the correct option. Okay, now the variance of the x bar. What is the variance of the x bar? Lambda over n. What is the variance of S square? So this is lambda square over n minus 1 square. What is the variance of this is 2 times n minus 1. So it will be 2 over n minus 1 into lambda square. Now you can compare them. What is the relation between them? Fine. So you can take any value. So say lambda is my 1. So if I take lambda is 1, so it is a 1 over n, 2 over n minus 1. So clearly say this number is less than of here. So it means this number is lambda over n, that is the variance of x bar, is less than of this. Can it be equal? It is not equal. You can see n minus n is less than of 2n, so it will never be equal. Fine. So that means this option is cancelled. Okay, the variance of the x bar attains the Cramer Rao. Again a very simple, x bar, or because for the Poisson distribution, summation of the xi is sufficient estimator of lambda. Fine. So it means if I divide it by, if I write here in terms of the x bar, it is my n into x bar is the sufficient estimator of lambda. Also it is given in the form of the interval, so yes, this is complete as well. Fine. So my target is to find this bound. Clear? So can you find this value? That's again a simple, attain the lower bound of lambda. So that means g is my here. You can find the value of the I can found this Poisson distribution, e raised to power this over x factorial. So as I explain you in this here, fine, it comes to be n over theta. So the same thing I can written here. So it is n over theta. So if I substitute this value, bound will be derivative 1 divided by here. So it is theta over n. So what is the theta is that? That's the lambda over n. So this is the same as we have obtained from this, because the mean of this is my lambda and it is my right answer. Okay, xi follows my here. Okay, can you identify the distribution? So you can see it's a theta times x of this. Can you identify which distribution which work on the 0 to 1? It's a beta distribution. So I can return this number as here. Fine. So it means x follows the beta distribution of theta comma 1. Fine. Then which of the following statement is true? The Cramer Rao bound of theta cube. So I can take g of theta is my here. Fine. So I need the I. So for that I need the L. So from here I can define the L. Sample size is my n. So theta raised to power n. Product of xi's raised to power here. So what is the log of L is n log of theta plus it will be summation of log xi's. Fine. Now take the partial derivative of this. It is n over theta plus summation of log xi. Take the second derivative. It is minus n over theta square. So therefore what is my I is expected value of minus of this thing. So this will be by here. So minus minus plus n over theta square is there. So I can substitute this value in the Cramer Rao bound. Cramer Rao bound is g dash over g dash square over I theta. So what is the g dash is 3 theta square over n by theta square. So it's a 9 theta raised to power 6 over n. So 9 theta square over is the right answer. Cramer Rao bound for this is theta square over n. That's the wrong answer. Now whether there exists any sufficient estimator or attains the Cramer Rao or not. Again a very simple. So you can see about that. From this case, can you find any of the unbiased estimator? So x follows my beta distribution of theta comma 1. Fine. And if you define the L, it will be of product of xi's. Fine. Or I can return this is log of x when you return in the form of the log n. Clear? So what does it mean is summation of the xi is my sufficient estimator of theta, fine, or you can say the summation of the log xi is my minimal sufficient estimator of theta, fine. So now I need the distribution of the log xi. So if xi follows my beta distribution of theta comma 1 minus log of xi will follow the exponential distribution of this, fine. Then what is the expected value of this? What is the expected value of this is 1 over theta, and you can see, and we need a 1 over theta, so that means this is my unbiased estimator, fine. He said there does not exist any unbiased estimator, and that is the unbiased estimator as well. So the right answers are A and D are the right answer. So although this is my MVUE, so it attained the Cramer Rao as well. Okay, so it's a 4 sample, draw from the normal distribution. So 1 over root pi e raised to power minus half x minus theta whole square, because sigma is 1. X bar will be my here. X bar will follow the normal distribution with the mu, with the mean is theta and variance is 1 over n. G is my here. L is my Cramer Rao of the unbiased. Then firstly I can find the value of the L. So it's a G dash divided by I. So for the I have to define the L, likelihood function. So this is a constant function. So I can return this is my L summation of x minus theta square. Now this is my log n, fine. So I can define this theta is by basically, yes, theta is my here. So I can define derivative of this. So it's a minus 1 summation of x minus theta. Theta will be the minus 1. Then I can take the second derivative. It will be x will be 1. So it is my minus 1. So it is my, how many summation size is 4. Fine. So what is my I? What is the G dash is 2 theta plus 2 whole square, and this is the expected value of minus 4. So this is the constant value, so it's a minus minus plus. So it will be theta plus 1 whole square over 1. And you can see this is the right answer. Why? Because you can see what is the my I is minus del square of log L. So I can see this minus and this minus is my positive. The first answer is the correct one. Now look at the second option, sufficient estimator. So can you find the sufficient estimator of this? So you can see if I open this bracket, it's a x square minus 2x theta. So what I told you in my last lecture, whenever you find the product form, so whatever the x and this value will be cancelled out. So summation of this x is my sufficient estimator, or I can need x bar. So x bar into 4 is the sufficient estimator. Fine. Since 4 is my constant, so x bar is the sufficient estimator of theta. Also, as I told you earlier, if A is the sufficient estimator of theta and f is my 1 function, then f of A is also sufficient estimator of the theta. Now if you look about there, if I take x bar plus e raised to power x bar, if I choose the function like of this x plus e raised to power x mu, and theta is the real number for this, so clearly say this function is my 1 function. So once x bar is the sufficient estimator of theta, so f of x bar is also the sufficient estimator of theta. Okay, look at this another one. Third option is, fourth option you can directly say what is the way. Okay, firstly I can check is a unbiased estimator. I can check whether this number is g of theta or not. Fine, because for the UMV we need a firstly unbiased. So if I start from the left hand side, if I open this bracket, this is x bar square plus 2 times x bar. Fine, x bar is my here. If I open this bracket, E of 1 is 1. What is the expected value of the x bar square? I can use the variance of x bar plus variance expected mean of square plus 2 times of x bar mean theta. So it will be 1. What is the x bar is 1 over n. N is my 4. So it is my 1 over 4 plus it is my theta square plus of 2 theta. So it is my 5 over 4 plus theta square plus 2 theta, which is not equal to g theta. G theta is my only here. So this means this is not unbiased. So once this is not unbiased, it means it is not UMUUE. How you can find the variance? So what is the, again you can see that same thing. This means here. So since this is my constant value, so yes, that's the same thing we have to find here, and this we have obtained this number. So since this is the equality and it's a half, so definitely this number is my greater than half. So this is the right answer. No, sorry, this is a false statement. Which one is the false statement? So that means C is the right answer of this problem. Okay, look at this one. It's a GATE examination. So n is my 5, sample size from here. So x follows my normal distribution, half comma sigma square. Okay, so this is my mean. Then sigma is my unknown. Capital T is the unbiased estimator of sigma square, such that the variance of the T is attained Cramer Rao lower bound. Fine. So that means basically T will be your uniformly minimum variance unbiased estimator. Fine, of sigma square. So what is the unbiased estimator of this? So since mean is my known, fine. So if the mean is known, what is that? It's x minus mu divided by n. As I told you in the earlier example, if the mean is unknown, then it's n minus 1. So this is my UMUVE. That's over. Then what is the value of the capital T? So I can substitute it. That means xi, mean is my half divided by n. N is my 5. That's over. So now xi's are given to be here. So what is my xi minus half whole square? Fine. So minus 1 minus half, 9 by 4, minus half minus 1 is a plus 1, 1 minus half, half is a 1 by 4, 5 by 2 minus 3, 1 by 2 is a 4 by 2, this is a 2, and 3 minus half, 5, 25 over 4. So can you find the sum of this? The sum will be, you can see it's my 5 plus it will be my 10, 20, 10 and 35 over 4. So it's a 20, 55 over 4. So if I substitute here 55 over 20, so that will be my 11, 4. So 11 over 4 is my right answer of this problem. You can write into the 2 decimal places. Okay, so n is my 5 is given to you. Xi follows my Poisson distribution with the parameter theta. What is the sufficient estimate of the Poisson distribution? X bar will follows the mean as 5 theta. Also this is given as a greater than 0, so this is my sufficient as well as complete. So let's say capital T is my summation of xi, which follows here. Then your target is to find the unbiased of x bar. So if I call this is my G condition T, this is your target. This is given as a alpha. What is the G? G is the all those values whenever x is less than 1, otherwise 0, and capital T is my here. So that means alpha will be expected value of the G condition, summation of xi will be, what is the sum of this? 4. Fine. Now I can substitute what is the expected value, this into this. So probability x less than 1 condition, summation is 4. So what are these possibilities? Either x is 0 or x is 1 condition, summation of x will be 4. Fine. So now I can return what is that. Now it's the intersection. What is the probability of A condition B? So this is probability of B, probability of A intersection B. So I can return this is, say x1 is my 0, and out of x1 is 0, how many elements are there? 4. So that means x2, x3, x4, x5, it will be my 4, divided by probability, this number is my capital T, this is my 4, plus again from here, if I choose x1 is my here, so that's the x1 is my 1 comma, rest number is x0, sorry, x2, x1, x3, x4, x5 is my, if 1 is there, the sum will be my remaining 3. Now I can substitute the value because they are the random sample. So independent, what is the probability of x1 0 by the Poisson distribution? E raised to power minus lambda over 0 factorial. What is that? So summation of the xi, I varies from 1 to 4. It follows the Poisson distribution with the parameter 4 theta because it has a 4 element. So it means e raised to power minus 4 theta raised to power 4 over 4 factorial divided by t follows my 5. So it is e raised to power minus 5 theta raised to power 4 over 4 factorial. Fine. Now plus similarly for this case, what is the x2 is 1, so again xi is my here, so it will be, I can write this component as here. Fine. So and I can clear this one. So plus for the first component theta raised to power 1 over 1 factorial, and again these are my 4 components, so it is e raised to power 4 theta raised to power 3 over 3 factorial, and the denominator is same. So that's over. Now you have to simplify it, so I can clear this. So clearly say e raised to power minus 5 cancel, e raised to power minus 5 cancel, theta raised to power 4 is also cancel. So from the numerator it is 4 raised to power 4 factorial divided by 5 raised to power 4 factorial. It is my 1 4 raised to power 3 over 3 factorial, 5 raised to power 4 over 4 factorial. So 5 raised to power 4 is a common, it is my 4 raised to power 4, it will be 4 raised to power 4. Now your target is to find this value, this is my alpha. So what is the answer of this? It is my 16 into 16 is 256 plus 256, 5 raised to power alpha, 5 raised to power 4 into alpha is my 512 is the right answer. Look at this another one. Again it's a gamma distribution with a parameter 5 comma 1 over beta. Then your target is to find the Cramer bound of beta square. So what is that? If I call this is my beta square, so the Cramer bound is g dash over I of theta. So I can define firstly the likelihood. What is the sample size is 8. 1 over 24 is my constant, so this is beta raised to power 5 over 8. X is my constant, so this is e raised to power summation of xi divided by beta. So I can define the L, it is minus 40 log of beta minus summation xi over beta. Then first derivative will be minus 40 over beta plus summation xi over beta square. Second derivative will be 40 over beta square minus 2 over beta cube summation xi. So therefore what is my I? Expected value of negative of this. So minus 40 over beta square plus 2 over beta cube summation xi. 40 over beta square is a constant, beta is my 2, so 40 over here. So this plus 2 over beta is my 2, so it is my 8. This is summation of expected value of xi. Now we all know if x follows the gamma distribution, what is the expected value of this? 5 over 1 by beta. So this value is beta is my 2, it is my 10. So I can substitute here, it is minus 10, 1 over 4, summation of 10. So what is the summation size is 8. So it is a 80. Fine. So minus, so it's a plus 1 over, it's a 2, it's a 8. So 1 over 4 into 80. So it is my 20. So that is my 20 minus 10 is my 10. So I can substitute here. What is the g dash? Is a 2 beta square divided by I is my 10. So beta is my 2. So 4, 16 divided by 10, 1.6 is the right answer. Okay, look at this another one. So n is my 2. Xi follows the Poisson distribution. Then the UMVE. Summation of xi will follows my 2 theta, and it is my sufficient. Plus, is it complete? Yes, because they are the open interval. So this is also the complete. So if I call T is my summation of xi. Then gamma cap is the UMV of this. This is the Poisson distribution. Fine. So I can return is a k to infinity. So x is greater than or equal to 4. So again, my target is to find the G condition, capital T. So what is the G is either 1 or 0. 1 when this condition satisfied, otherwise 0. Fine. So I can define this gamma cap is probability of x greater than or equal to 4, condition capital T. Capital T is my sum of xi. What is the sum of xi is 5. 5. So it means it will be x is 4, condition x1 plus x2 is 5, or it will be 5, condition x1 plus x2 is 5. Now I apply the definition of this. So I can choose x1 is my 4, then x2 will be my 1 divided by probability of x1 plus x2 is 5. Similarly from here, if I choose x1 is 5, then x2 will be 0 divided by probability of this. So now they are the random samples, so they are independent. So what is the probability of the x1? That is a Poisson distribution, e raised to power minus lambda over 4 factorial, e raised to power minus lambda this over 1 factorial. X1 plus x2, here again it follows the Poisson distribution, so I can return this is minus here 2 theta raised to power 5 over 5 factorial, e raised to power minus theta 5 over 5 factorial, e raised to power minus theta 0 over 0 factorial, and again it is my same. Now again you can see e raised to power 2 theta will be cancelled, theta raised to power 5 is also cancelled. So what is the remaining part is 1 over 4 factorial over 2 raised to power 5 over 5 factorial, plus theta raised to power 5 will be cancelled. So it is 1 over 5 factorial, and it is 2 raised to power 5 over 5 factorial. So I can again cancel out the 5 factorial. It is 5 over 32 plus 1 over 32. So 6 over 32 is the right answer of this problem. You can convert into the 2 decimal places. Look at the last question. N is my 3. Okay, can you identify which distribution is here? Any of the distribution will start from here. That means it's a discrete distribution firstly, and it is a geometric distribution. Fine. So what is the, if it is a geometric distribution, what is the minimum, what is the sufficient estimator? This is my sufficient estimator. Also it is given as an interval, so it is my complete. Fine. Now if I called capital T is my summation of xi. So what is the summation of the geometric distribution? It follows my negative binomial. Fine. So what is the size is 3 and parameter is theta. Fine. Then T is the unbiased estimator of theta square. So if I call G is my theta square, how you can define the G? Again, your target is to find this value as G condition. How can you define the value of the G? How you can make them as a theta square? So clearly say, if I take x is 0, it will be the theta. So it means I can take 1, 0. If x1 is 0, x2 is my 0. Because what is the probability of x1 0? What is the probability of x2 0? X follows my here. So it means it's a theta. It is theta. So it means I can say the product of them, this is theta square. So that means the two elements, otherwise 0. Fine. Or you can take either x2 is a 0, x3 is a 0, or you can take x1 0 or x3 0. There is no issue about that. Now that's over. Once you identify this, I can start from the tau cap. What is that? It's the probability of 1. What is the probability of G? That is a 1 into this. x1 is equal to 0, x2 is equal to 0. Condition, summation of xi is, what is the sum of this? 7 and 11. So how I can define x1 0, x2 0, and the sum of the 3 is my 11, and the two elements are 0. The third element must be 11. Fine. This is capital T is 11. Now I can apply, these are the random samples, so independent. Probability of x1 0 theta, probability of x2 is 0 theta, x3 is my here. Fine. Now what is the PDF of the negative binomial? So if I call f of t, what is that? This is 2 plus t c here. I can write here. So what is that? PDF is 2 plus, because it's a negative binomial, it starts from the 1 minus. So theta cube 1 minus theta of square. So I can substitute as a 11. So it's a 13c 11. Fine. 13c 11 into theta cube 1 minus theta of 11. So you can see this number will be cancelled, cube will be cancelled. So it will be 13c 11, basically 13c 2. So it is 1 over 13 into 12 divided by 2 into 1. So it is 1 over 13 into 6. So tau cap is my 1 over 13 into 6. And your target is to find the 156 into 13 into 6. So it is 1, 12, 6, 2. So 2 is the right answer of this problem. So this is the way you can solve all those PY question series related to the Cramer Rao and the MVUE problems. We will see the more lecture in the coming examinations or the coming videos. You can simply like, share and comment on my video. Best of luck students. Happy learning.